Before I start this video, the objective is to help people who may be overwhelmed by trying to understand the complexity of artificial intelligence, which is not simply a new piece of tech, but something which is already changing society. And hopefully this will become clear as we go through this video. Explaining AI is not that easy, and obviously understanding it is not easy, and may be one of the reasons why people just try to ignore it as much as they can, as they haven't much of an idea of what's going on, and maybe even if they wanted a bit more clarity, they possibly don't know how to go about it. So as my background many years ago was in computing and microprocessors and so on, although I'm not up to date with all the latest technology in any kind of detail, I do have quite a good understanding. But what strikes me is that we need to look at it on several levels. It isn't just one thing. Some people think it is software, piece of software. Some people think it's the latest gimmick or the latest thing to play with on the internet, but there's much more to it than that. Financially, there are massive implications, not least because a lot of big tech companies are putting a lot of money, we're talking millions and billions of pounds being invested, almost, it seems to a lot of people, in a very reckless way. The societal aspect, everybody knows. I think that the internet changed society quite a lot, and then when the mobile phone came along, the changes were even more significant, and mobile phones have literally changed the way that people behave and the way that they interact with each other, or perhaps not interact. The political aspect is also very important because the main reason I'm including this, it can't be ignored, is that governments are influenced by AI in this case, just as they were with mobile phones and the internet, and governments are not in control, and maybe people are pleased that they're not, but big tech and the big tech companies are in control because they are developing AI at a massive rate, and they don't do this by discussing with the government or with society. They just go ahead as fast as they can, and they get very excited about the technical aspects of what they are developing. Again, as I said earlier, in a kind of reckless way. And if people are unaware of what is going on, the chances are that they're going to get, and a lot of people are going to get, a bit of a shock in the next, within the next couple of years even, as AI gets more and more sophisticated, successful. Lots of companies, large companies, small companies, are investing in it, possibly doing this when they don't really know what it is that they are investing in. So one of the things I thought would be useful is to look at AI in terms of numbers. Not that that's going to explain everything, but it certainly could be a useful exercise. And as we can see here, when desktop computers took off, and PCs and computers in offices and so on, people became familiar with kilobytes, which were thousands of bytes, megabytes, which were millions of bytes, and then gigabytes. And we're perhaps familiar with these terms, especially gigabytes, in terms of memory on PCs, RAM memory, and hard disk drives, which are typically in gigabytes or even terabytes. Big tech talks a lot about big numbers. A lot of the time they're doing this in terms of money and dollars and millions and billions of dollars, because that's what they like to do. But big tech is also dealing in terabytes, which are 1,000 times bigger than gigabytes, and petabytes, if anybody's ever heard of those. They are, whereas megabytes are 10 to the power 6 and gigabytes are 10 to the power 9, terabytes are 10 to the power of 12 and petabytes 10 to the power of 15. So we're talking about 15 zeros, which is massive, absolutely massive. And the word peta will come up again when we talk about computer speed. So as you can see on the screen now, as I was just saying, kilobytes are 1,000, which is 10 to the 3. Megabytes are 1,000,000. Gigabytes are 1,000 million, or billions, but in tech, the word billion isn't used, but it's gigabytes, but it's the same number. And then we've got terabytes, and as you can see, petabytes is a massive amount of memory. Everything just gets bigger and bigger, almost as if you can't control it, and it gets faster and faster. But that just illustrates numerically what I'm talking about. So as you can see here, looking at some more numbers, because we need to look at the various levels of artificial intelligence, as I mentioned earlier. And I saw this comment where somebody said we need a science for understanding AI. And I thought that was a very good point to make, because people really do need to understand AI as much as they can. And the more ignorant they are of AI, in many ways, the more disadvantaged they will be. And then it occurred to me that in schools, children would benefit from having AI explained to them, even if it's only in simple terms. Otherwise, it just becomes a complete mystery, and maybe something that then is just ignored, which is not good. So, and then I thought maybe the time will come when children, older children, in perhaps junior school, but certainly in secondary school, will be studying AI, not learning how to interact with AI or how to use AI instead of using their brains, but actually understanding what it is. And maybe the time will come when somebody's doing a GCSE in AI or an A-level, and then of course going to higher education and so on. But all that kind of thing, that level of education, is going to be essential really for people to know what's going on. As you can see here, if we consider at this stage the human brain and how it operates, there are also some very big numbers there, and there are in the normal human brain something like 100 billion neurons, or nerve cells, or whatever you want to call them. But there are also a massive quantity of connections which can be made to each number. And that, I wouldn't say it's a simple diagram, but the diagram there illustrates that each neuron could be connected to as many as 100 trillion, not all at once, of course, but that means that those are the possibilities of 1,000 million connections possible for each one of 100 billion. I mean, these are huge, huge numbers, but the technology and electronics can go way beyond these numbers, as we'll see. But the human brain is incredible, and when you look at these numbers, it goes a long way to explaining how we can do so many complex things throughout our life. as we learn and use our memory and so on. Before we leave this numbering at the moment, because I'm going to do more of this in the next video, each of these neural connections can be achieved at a speed of 200 calculations per second. But as we can see here, electronic circuits can do this 10 million times faster or thereabouts, which is a bit mind-boggling, to put it mildly. So hopefully it becomes clear at this point that these fantastic speeds of tech are going a long way to enable the growth and the power of AI. So in the next video, I'm going to be using numbers again to partially explain AI, because it's not just all about the numbers, there's all the other factors that we mentioned earlier. And as I'm saying here, it's the tip of the iceberg. Next time I'll use more numbers to actually make some comparison with the human brain, and obviously compare the human brain to artificial intelligence. The difference being that the human brain is more or less a constant, but artificial intelligence is growing as we speak, of course.